quick follow-up to the last video in which we were introducing the concept of a function and what they are in terms of how they relate to a relation, why are they special, and how one can represent them, and also how can one tell if a relation is also a function or not. And where we left off, we were discussing this function up here, letter C, in which we did determine that it was a function. So we say y is a function of x. If we can isolate y and determine that for every x that we plug in, it's going to go to one and only one output. So we're going to continue this discussion by looking at example D very briefly, and then E, and then finish up this video. But take a look at this relation over here where it says x squared is equal, or excuse me, x squared plus y is equal to 1. Okay. So our intent here is to determine whether or not this is this relation is also a function. So one way to do it is to graph it. Another way would be to make a table of values. But necessarily algebraically, what we can do is we can isolate y to determine if it is itself a function of x. So in order to isolate y here, what we'll do is we'll kick this x squared term to the other side by subtracting it from both sides. That's gone, and we end up with this. It yields y equals negative x squared plus 1. So again, we could make a table at this point. We could graph this. We could plug it into a calculator and see if it has a graph in which a vertical line would anywhere intercept it, excuse me, more than one time. But in this instance, what I want you to do is just kind of think to yourself, if we had plugged in any x value in the world in for x right now, would there be any possible way that it could spit out two distinct y values? And in this instance, we could not pick any x value, so long as it's a real number, such that it would spit out two y values. Okay, so we could also determine that this one here is a function. So we say y is a function, oops, of x. Kind of went off the screen there. Y is a function of x. Okay, so let's look at example E here, and we'll talk about some function notation, and then we'll move on. We say, okay, our intent here is to isolate y. Our question is y a function of x? So to isolate y, let's start by getting rid of this x term here. So subtracting x from both sides. See that y squared is equal to 1 minus x. Now here's where it gets a little bit interesting. In order to take care of this squared, what we're going to do is we're going to take the square root of both sides. Maybe I'll make that red. Square root of both sides. Ooh, kind of missed there. There we go. So we have y is equal to the square root of 1 minus x. And one might necessarily kind of infer now that this, represents a function of x. Y is a function of x. But what I want you to realize is this. Because this radical has an even index, that is, we're taking the second root, or maybe the fourth root, or the sixth root, or the eighth root, but in this case, the square root of this, we do have to, on the outside, include both positive and negative possibilities. So the interesting thing here is this. If we, say, necessarily picked, I don't know, an x value, let x equal negative 3, you would necessarily see that we'd have y equals plus or minus the square root of 1 minus, we plug in negative 3. We say y equals plus or minus square root of 1 plus 3, which is 4. And so we end up with y equals plus or minus 2. So the interesting thing to note here is this. When we plugged in an x value of negative 3, we not only went to a positive 2, but it also mapped on to a negative 2, thus ruling out this as having y be a function of x. So this is not a function, not functional. Okay. Yeah. So real quick, let's talk about function notation, okay? This is something we've probably all seen before, but you'll notice right here I've already written a function. We say let f of x, and that's how we say that. Let this function of x be equal to x squared plus 4, okay? So just to kind of maybe paint that in a little bit darker for us here. X squared plus 4. I want everybody to know that this is the same thing as saying y equals x squared plus 4. So we're saying y is a function of x. So therefore, we'll call this function f. So the name of the function is f, but we're saying this is the y value at a given x value. So this f of x is the function value at this specific x value. Okay. And this is important that we list things this way because we often tend to write functions in this fashion, and it's convenient because we may say something like this. We say, well then, in this instance, let's find f of 1. So here's the important thing for me that I want to point out to everybody. this f of 1 really does represent a y value. I'm actually going to list it like this. When we find f of 1, that's like saying when x was 1, then we got a y value of this. In other words, when x is 1, this is the function's value at an x value of 1. We're plugging 1 into the function and spitting out this y value. This is not, however, the same thing as saying f. F is the name of the function. When we say f of 1, we're saying that is the value of the function when x is equal to 1. Okay? So now, kind of taking this a little bit further, we say f of 1. Let's go and evaluate this function for an x value of 1. So the important thing to remember here is this. F of x was equal to x squared plus 4. So when we plug something into a function, say, what we're necessarily saying is, wherever we saw an x, okay, and we had x squared plus 4, we'll take it out, and I can only implore that you put in a blank set of parentheses. Because whatever goes inside this set of parentheses over here on the left, that's what we're going to insert on the right. So you notice here we have 1 squared. If we say 1 squared is 1. 1 plus 4 is 5. So we say f of 1 is equal to 5. This is equivalent to saying that when x was 1, we got a y value of f of 1, or we got the function value when x was 1, and the function value when x was 1 came out to be 5. Okay, it may be the case that sometimes we don't want to find f of 1. We would say find f of, I don't know, t. Okay, so the same kind of rules apply. Wherever we saw an x previously, we'll take it out and we'll just plug in a t. So f of t would necessarily be defined as t squared plus 4. So another way to write this would be to say that when x was t, we got a y value of t squared plus 4. And then, one more real quick example, because we're going to be dealing with composite functions soon. What if I wanted f of x plus 2? And this tends to throw people off, okay, just because we have more than one thing inside this parentheses. But again, if we keep it simple, and we're admitting that all we're doing is wherever we saw an x in the original function, which was right here, we're going to go ahead and remove that and instead insert what we plugged in over here. So in this instance, f of x plus 2, we get x plus 2 quantity squared plus 4. Okay, now keep in mind we can't distribute a squared through a summed or a difference quantity here, okay? So we have a sum. So let's go ahead and write this out. This would be like x plus 2 times itself plus 4. And if we go ahead and carry out our FOIL here, we would end up with x squared plus 2x plus 2x plus 4, and then plus 4 off on the right. So we end up with a final quantity of x squared plus 4 total x's, trying not to go off the screen here, plus 4 total constants. Okay? But let's get used to this function notation, because we're going to use it often.